Hello and welcome to Enabling F5 Distributed Cloud Fraud and Risk Services with ForgeRock Connector. My name is Kyle Roberts. I'm a Senior Technical Marketing Engineer with F5. In this demonstration, we'll show you how customers can now utilize F5's industry-leading Distributed Cloud Account Protection and Authentication Intelligence services with ForgeRock's Customer Identity and Access Management platform, bringing immediate security action and protecting their digital businesses against fraud. Breached login credentials, PII, payment information, and other identifiable information lead to fraud. Credential attacks have become the biggest cause of extreme financial loss over the past 5 years. The result is lost revenue due to churn, bad public reviews, and lowered CSAT scores, and increasing fines and penalties due to new regulations like GDPR and CCPA. ForgeRock is a global leader in the identity and access management space and offers a range of digital identity solutions across industries that help consumers, employees, and even Internet of Things to simply and safely access the connected world. ForgeRock solutions help more than 1,300 organizations around the world orchestrate, manage, and secure the complete identity lifecycle across cloud and hybrid environments. ForgeRock and F5 work together to deliver easy access to powerful solutions that defend against a range of fraud and abuse. Distributed Cloud Account Protection monitors every transaction in real time across the entire user journey to determine the intent and fraud risk. This cutting-edge solution detects and eliminates online fraud with AI powered by a real-time closed-loop engine that stops illegitimate activity before it happens. At the same time, Distributed Cloud Authentication Intelligence identifies multiple users on one device, determines user intent, and maintains a globalized historical profile, all to make life easy for good users, but hard for everyone else. With this solution, customers can securely enable trust across the entire customer journey without negatively impacting real users. Available as a SaaS managed service and deployed via a simple plugin connector, Distributed Cloud Account Protection and Distributed Cloud Authentication Intelligence deliver real-world fraud prevention and continually maintain and update their knowledge and capabilities to reduce fraud on an ongoing basis and remove friction from the user experience. Now, let's jump into the product demo to see the service in action. Let's begin our demo on the ForgeRock Marketplace by navigating to backstage.forgerock.com. From here, you'll search for F5 and it will bring you to the F5 connector page for the necessary steps to build the ForgeRock Access Manager and build the auth tree according to the documented steps. Once the ForgeRock Access Manager is built and the GitHub project files have been integrated, you'll be able to access your ForgeRock Access Manager console and begin creating the authentication tree and passing configuration variables to your nodes. Let's navigate into our top-level realm and click on Authentication Trees to begin building the authentication workflow and configuring the account protection and authentication intelligence services. Now let's build our tree according to the documentation on the connector page. With a completed F5 authentication tree, we can now begin configuring the account protection and authentication intelligence settings within the F5 Distributed Cloud ForgeRock configuration node. This common configuration settings window allows us to configure both account protection and authentication intelligence settings. Now let's walk through our configuration settings for our use case demonstrations. We'll start out with the JS path front end by giving it a user-defined path and name. Then we'll need to configure the customer ID, which needs to be obtained from F5. The cookie name that we've configured and that we'll be looking for is imp_apgr. And we've configured the required cookie decryption key. The flag for JS injection toggle button is required in order to collect the required client signals for both account protection and authentication intelligence. The default session time is the max session time used for any user without any session extension recommendations from authentication intelligence. For this use case, we've set our default to 2 minutes. The F5 session user attribute name is a user attribute available in the data store of ForgeRock. This user attribute will be used by the F5 plugin to save session-related data. For testing purposes, we can use any existing user attribute, for example, telephone number for our demo use case. The Account Protection Enabled toggle button is used to enable or disable the Distributed Cloud Account Protection actions The FR equals 2 and FR equals 3 fields define the specific endpoints that account protection is monitoring, and what action is to be taken when the collected fraud signals appear malicious. For example, if we're monitoring the login endpoint, our possible actions are block, continue, and redirect. The Authentication Intelligence Enabled toggle button is used to enable or disable the distributed cloud Authentication Intelligence actions based on user journey signals for session extension. The endpoint actions for session extension define various URLs of the login initiating point and what action is to be taken. When the recommendation is extend, the possible actions are extend to extend the user session based on the F5 recommendation, and default, which ignores the F5 session extension recommendation and lets the user log in with the default session time only. Now let's jump into our Authentication Intelligence use case demonstration. Now let's have a look at the user identity that we'll be testing with. If we browse to the top level realm and go to Identities and click on E1, we can see the user attribute that we specified in our configuration for testing purposes. This is the user attribute that will be used to record the session information and recommended action. Now let's see what happens when E1 logs into our demo web application. As the user accesses the application, Authentication Intelligence is collecting telemetry about the client, examining network, hardware, and software signals, such as has this user logged in successfully in the past? Is this device operated by a single human user? And does our risk engine determine this device and account are safe? But the E1 user is getting a recommendation of DC equals INE, which is ineligible for session extension. Even though the action on the endpoint configuration was extend, since the user gets DCINE, the user will only be granted the default session extension, in this case 2 minutes, based on our configuration settings. Now let's have a look at the specified user attribute in the E1 user account within the ForgeRock portal. The max session time says 1958 and the last access time is 1956, which tells us that this is set to the default session time of 2 minutes. Back inside of the demo application, if we refresh the page, we can see that our session has exceeded the 2-minute extension and timed out. Now let's observe the user experience when the E1 user receives an eligible for session extension response. When user E1 signs in on the login page of our configured endpoint, we'll look inside of the cookie, and we can see the recommendation of DC equals E7, which means eligible for a 7-day session extension. Since the action configured on this endpoint is extend and the E1 user now meets the good user requirements, the user is granted a 7-day session extension. Let's again check the F5 session user attribute for telephone number of the E1 user account in ForgeRock, and we can see our last access was on 4/11, and the max session time is set to 4/18, which indicates a 7-day session extension. Now let's refresh the page of our web application, and the E1 user's login session will persist well beyond the previous 2-minute timeout. The E1 user session will persist over the next 7 days, reducing login friction and greatly enhancing the user experience. Now let's jump into our SaaS-based distributed cloud platform to check the Authentication Intelligence dashboards and insights available after deploying this service. From F5's Distributed Cloud Dashboard, let's click on the Authentication Intelligence tile to access the service. Once the JavaScript has been injected, the data collection process begins and the risk engine is enabled to identify good users returning to your site. A dashboard is now available with user login friction insights. The depth of data provided by the dashboards allows you to see how login friction persists over time. This data helps show how many of these users can have their login experience improved by leveraging Authentication Intelligence to extend their session. After sessions are safely extended to good users, you begin to see conversion increases from customers who are enjoying a more satisfying user experience due to the benefits of Authentication Intelligence. We provide you the visibility you need to see how many users are enjoying your services with a frictionless login experience. You can even see over time how many additional conversions or purchases are generated because of removing friction to known good users. Inputting the average customer transaction value allows you to estimate top-line revenue lift and actually see the tangible benefits of the service. You can see further improvements to be achieved by extending to a longer session and improve auto-login implementation. F5's distributed cloud Authentication Intelligence provides you the visibility and capability to rescue real users lost due to login friction. Now let's take a look at our demo environment being protected by the Account Protection ForgeRock Connector. Looking back at our ForgeRock Access Manager in the FR configuration node, let's make sure that our key configurations are in place. We have our JS path configured, our cookie name and decryption key for the cookie, flag for JS injection is enabled, and the account protection toggle is switched on. We have our endpoint defined and we'll be demonstrating two different actions, challenge and redirect, to show how account protection monitors every transaction to obtain real-time predictions on risk levels, stopping fraudsters in their tracks. We've created a very simple scenario for this redirect use case to trigger the redirect action. We're protecting the shop endpoint here, and as the user is interacting with the site, we're detecting any anomalous interactions that indicate fraudulent behavior, we're collecting high-risk actions that the user or device has taken, and we're looking for any inconsistencies in the browser, device, and network. Collectively, if these signals trigger a high enough risk, they will get redirected to a specified page. In our next demonstration, we're protecting the contact endpoint. And again, we've created a very simple scenario to trigger the challenge action. Since we monitor every transaction, we're again monitoring user journey signals, behavioral and environmental insights. We also use insights from our global network of threat intelligence, allowing us to identify new fraud patterns faster across our global intelligence network. Collectively, out of the hundreds of client signals that we evaluate in real time, if the fraud risk is high enough, the recommended action will challenge the fraudster, in this case with a 6-digit code that they cannot satisfy. Now let's jump into our SaaS-based distributed cloud platform to check out the account protection console dashboards and insights available after deploying this service. The Account Protection Console provides a smart portal for fraud teams to analyze suspicious transactions within their applications, so they can take action quickly and with confidence. We have a filter pre-configured to only display transactions with a recommendation of block or suspicious, and we're sorting them by risk score from highest to lowest. If we look at the fourth line with user Bruce Wesley, let's expand the fraud reasons. We see many account attempts, pasting text, and others as well. We can also see that in the feedback column, there is none yet recorded. Admins can provide feedback regarding whether or not they think a transaction is fraudulent, or an entire user session that includes the transaction as fraud. This enables the AI models used by account protection to more accurately determine which transactions are suspicious and which ones should be blocked. Now let's open up the transaction for more information about the AI decisions behind this event. Looking at the transaction, we see the summary displaying the risk score, recommendation and fraud reasons. The event information has timestamp and URI info, and the user session information is showing the single transaction, but can display correlated events that share the same session ID and device ID. We also notice that the network information shows this transaction from Russia, which is not common for our application. This transaction looks suspicious, but let's go ahead and search our transaction log for this particular device ID and see if it can help our investigation on Bruce Wesley. We've copied the device ID, so let's add it to our filter. After the filter has been applied, we see 6 different accounts from this one device ID, all coming from different IP addresses and ASNs. Let's expand the fraud reasons, and we see many known fraud signals as well. We now have high confidence that this is a fraudulent transaction. Let's go ahead and submit our fraud feedback on this one. There are many benefits that customers can gain by deploying F5's distributed cloud fraud solutions with the ForgeRock Connector integration. They can slash fraud and abuse, increase top-line revenue, remove friction for good users, and maximize app security against manual fraud. To learn more, please visit f5.com/ForgeRock or contact ForgeRock@f5.com. Thanks for viewing. We'll see you next time.